students, myself Santosh, and you're watching my channel at the rate Gain Knowledge World. Please subscribe my channel, like and share, and please ensure to press the bell icon for the latest update of the. So the last day we had completed the chapter triangle, okay, and I have told you to do this exercise, which is last exercise of this chapter, which is 7.5 and optional for the chapter. I hope you had completed the whole exercise by your own. If not, you can comment in the comment box. I will do it for you. Okay. Now coming to today's chapter number 8, which is quadrilaterals. Okay. This is the introduction of what is the quadrilateral. What a quadrilateral means. It means if there is I can say a figure, there is a figure, any figure which have four sides. A figure which has four sides and four vertex due to joining of the all sides, okay, is called a quadrilateral. Either the sides are equal or unequal. Let us see the this example. Example number first. ABCD is a what quadrilateral. The all the sides are not equal to each other, but it has the 4 points and has a four side. In day-to-day life, you can see the blackboard in classroom, or this maths books, or a table, or any of the substance which is like have four sides with four angle or a point of joining it is a quadrilateral. Now coming to the point 8.2, angle sum property of a quadrilateral. What is the angle sum property of a quadrilateral? It means is if there is a quadrilateral, let's suppose this is a quadrilateral, okay, the whole sum of all the angles should be equals to 360 degree. Okay, here the example number, this is not the example, it is a proof you have given in the. Here you can see that ADBC, which is given here, is equals to 360 degree. The sum of angles of quadrilateral is 360 degree. Now here's type of quadrilaterals. What type of quadrilateral? This is the also a type of quadrilateral. This. It means it is a trapezium. If we in the next classes or in this chapter maybe, it is a trapezium. It is rhombus. It is a rectangle. Sorry, because the length of facing each side, facing toward each other, this both side and this both side are equal. Okay, this is also a I can say rhombus, because in rhombus all the sides are equal like a square, but it is little tilted. This is the square, all the sides are equal, as you know, and this is what is a kite. Okay, in which these two sides are equal and these two sides are equal to each other. Now coming to a point 8.4, properties of parallelogram. What is the properties of parallelogram? Now by theorem 8.1 we can get what are the properties of it. The theorem first is, which is 8.1, a diagonal of a parallelogram, this is the diagonal AC, divides it into the two congruent triangle. It means is, what is congruent triangle? Means equal triangles. As I told you before, what is congruent? Congruence means equal. So there is a diagonal. If AC is a diagonal, then ADC and ABC both are equal or congruent triangles. Now coming to theorem 8.2, in a parallelogram opposite sides are equal. What it means is this angle D and B will be equal if it is a parallelogram, and angle A and C will be equal if it is a parallelogram. Now theorem 8.3, if pair of opposite side of a quadrilateral is equal, then it is a parallelogram. How? If this and this is equal, this and this is equal, then it is a parallelogram. Why? As I told you before, because in a triangle or a parallelogram the opposite sides are equal. Okay, the difference in rectangle and parallelogram is the parallelogram is little tilted, like this, little tilted is a parallelogram, and if it is in the straight line then it is equals to a rectangle. And the other difference is this angle is, as you know that this is angle is more than 90 degree, but in the or this angle is less than 90 degree, but in the rectangle all the angles are always be 90 degree. Theorem 8.4, in a parallelogram opposite angles are equal. As I told you before that opposite angles are equal. Now in theorem 8.5, if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. The theorem 8.5 is telling us the same thing but in the other way. It means, if you relate with me, that it is a like passive voice and it is a sorry, it is a active voice and this is a passive voice of both the statements. It is like only for example, it is not the same thing because I am not relating maths with English. Both the subjects are different, but I am just relating to make you better understand. Now, the theorem 8.6 tells us that diagonal of a parallelogram bisect each other. What it means is, if AC is a diagonal, BD is a diagonal, both are the diagonals of parallelogram, then both the diagonals equally distribute each other. Means AO and OC will be become equal and DO and OB will be equal. What is in the theorem 8.7? If a diagonal of a quadrilateral bisect each other, then it is parallelogram. Again, the same thing which I told you in theorem 8.5 and 8.4. And this is if it is a active voice, and this is the passive voice. The meanings are same, only the form of written is different. Now coming to example number 1, so that each angle of a triangle is right angle. Okay, in a triangle we know that, sorry, in a rectangle we know that AD and BC will be parallel, DC and AB will be parallel. Okay, so let's suppose AD and BC be parallel. If it is a parallel, then the angle which is transverse, then the angle made by A and the angle made by B is equals to 180. Okay, and here we let's suppose that angle A is 90. Okay, so if it is 90 and the parallel lines are going through this side and AB is the transverse of AD and BC, then this angle will be also 90 because 180 minus 90 will be 90. Again, AB and ADC are also parallel and AD and BC are transferred to both of them. So if we take this as a transverse, AD as a transverse, then this angle is equals to this angle. How? 180 we will subtract by the interior angle 180 minus this angle A, which is 90, again 90, and by this again 90. So we had proved that all angles of the rectangle is 90. Now coming to example number 2, we have to show that the diagonals of rhombus are perpendicular to each other. Firstly, we should know that what is rhombus means. Rhombus is nothing but a tilted form of a square, okay, in which all the sides are equal like a square, but the diagonal, and the second thing is what? The same thing as a square, the diagonals cut each other equally. Means AD and AC both cut each other, like AO is equals to OC and DO is equals to OB. So by this, we in for proving this question, we had taken the what, triangle AOD and COD. How? And we have to prove the, so in this triangle you can say that AO is equals to OC. Secondly, AD is equals to DC. Why? Because the side, same side of square or rhombus, and DO is the common. So by SSS congruency rule, AOD and DOC will be congruent. And if it is congruent, then we can prove that this angle AOD and angle COD is equals to 180. Why? Because of the linear pair. The whole line AOC will make the 180. And if it is 180, then because of congruency, this angle and this angle both are ADOC and DOA, both angles will be equal. And if we have to this we have to distribute this 180, okay, in two equal parts, then what is the answer we get? The 90 degree only. Means we have to get 90 plus 90, then the 180 will be the final answer for the linear. So this angle will become 90 and this angle will become 90, because of which we get that rhombus are perpendicular to each other like a square. Example number 3, what says as ABC is an isosceles triangle in which AB is equals to AC. AB bisect exterior angle PAC and CD parallel to AB. Then so that DAC is equals to BAC. How it is going to be possible? And the second, ABCD is a parallelogram. Now we can see that in ABC is an isosceles triangle, so AB and AC are equal, and CD and AB are parallel to each other. Okay, so first of all we take this angle and this angle equal. Okay, and this angle PAC, the whole PAC is equals to this B angle plus C angle. Why? Because of exterior angle. We know that opposite exterior, the opposite angle will be sum of this. Okay, now PAC is equals to, we can say that 2ACB. Okay, ACB, because ABC and ACB both are equal, so because of the sides, so 2ACB is the first equation letter. And the second thing we got that AD is a what, bisector of angle PAC. So if this is 2ACB, then this angle is 1ACB and this angle will be 1ACB. Now we had proven that angle DAC is equals to ACB. How? As I told you before. Now we have to prove ABCD is a parallelogram. By this we can prove that AD and BC is a parallel to each other, and AB and DC is a parallel to ACD and AB are given parallel to each other. But by this angle proving, we had also proved that AB, AD and BC are parallel. And if any of the quadrilateral have two sides parallel to each other, then it is a parallelogram. Okay, now coming to example number 4. Here the question is what? Two lines parallel L and M. L and M are two lines parallel and intersect by transverse. P is the intersecting transverse line, so that quadrilateral formed by bisector of interior angle is a rectangle. We have to prove that BCDA is a rectangle, not parallelogram, rectangle. So let's suppose if this line and this side L and M are parallel to each other, then this angle PAC and this angle RAC will be equal, and half of it, this angle will be equal also. Okay, this angle and this angle also be equal. And if this angle is equal, then AB parallel to DC and ACB parallel to AD. We have proved that ABCD is a parallelogram. But we have proved that ABCD is a parallelogram, but we have to prove what? We have to prove rectangle. Okay, so for rectangle what we do is, let's suppose not let's suppose in PAC and CAC, this PAC, this angle, and CAS, this angle, both the angles make 180. Okay, halving the both angle we get 90. Okay, so BAC and DAC will be get 90, and by 90 we can say that if we add both the angles we get BAD is equals to 180, sorry 90. So this angle becomes 90, and because of this angle 90, there is a only quadrilateral in which if the sides are parallel and not equal, the sides are parallel and the side facing to each other are equal, then there is a only quadrilateral we know is rectangle and have a 90 degree of angle of all. Now example number 5 is, so that bisector of angle of a parallelogram from a rectangle. Now we have given the parallelogram and you have to prove the rectangle. Okay, so this question will be done by you. You will try. If any problem came, I will solve it for you. Now coming to another condition 8.5, another condition for quadrilateral to be parallel. Parallelogram. What are the conditions? theorem 8.8, which is a quadrilateral is a parallelogram if the pair of opposite sides equal and parallel. As I told you before that in a parallelogram the pairs of opposite sides should be equal and should be parallel. And what happen if all the sides will be equal, then it will become rhombus. Okay, this is example number 6. ABCD is a parallelogram in which P and Q are midpoints of opposite sides A, B and CD, which means this and this equal, this and this equal, and this angle will be equal to this angle will be equal to the this angle and all that. Okay, if AQ intersect DP, AQ intersect DP, okay, means this and this angle also become equal, and at S, and BQ intersect CP at S. Okay, not it is not given, only thus this and this equal are given, and angles we will get by parallel. Okay, so that APCQ is a parallelogram. DPBQ is a parallelogram, and PSQR is a parallelogram. Okay, as per I know and I have told you before, it is a very easy, okay, to solve the question, and we will move ahead towards the exercise 8.1. But due to some I am not due to unavoidable circumstance, which is I am feeling not so good, so we will quit this session here, and then next whatever the video will come, in that I will clear the whole chapter using approximately the all questions as I do in all the exercises and examples. So this was for today. Okay, hope you guys understand and enjoy the session, and if it is not, please comment in the comment section box what is the missing in bit. Okay, so thank you for today, and please subscribe my channel, which is at the rate gain knowledge world. Subscribe it, like it, and share with your friends, and press the bell icon for the latest updates. Thank you.